Welcome to Aviation. Let's cover elevation, height, altitude, flight levels, pressure altitude and density altitude, so there is no more doubt. Elevation is the vertical distance from mean sea level to a point on land, like the runway of an airport. This vertical distance is calculated by the local pressure at the airport or station and is called local altimeter setting. When you place this number in your altimeter window, you will see the elevation above mean sea level. Height is the vertical distance above ground level, abbreviated as AGL. Altitude uses the same calculation as elevation, but now for a moving aircraft and not a fixed point on the ground. The altitude is the vertical distance above mean sea level, using the local pressure of the area as a local altimeter setting. Since pressure is different in local areas, you have to reset your local altimeter setting in your altimeter when moving into an area of different local pressure. Remember that the altitude is linked to this specific local pressure area, and if you do not change it when moving into an area of different local pressure, you will read a wrong altitude on your altimeter. When two aircraft have set their correct local altimeter setting for their area, then both of them will see the correct altitude in their altimeter, even when both of them can be in different local pressure areas. Here you can see that both aircraft fly at an altitude of 8,000 feet MSL, but both in different local pressure areas. Both have the correct local altimeter setting and are thus they both fly at the correct altitude. Suppose that the one pilot in the relative high pressure area forgot to reset his altimeter to a higher local pressure setting. His altimeter measures a higher pressure in its system than set and correct its altitude read out to a lower altitude. Remember that higher pressure is lower to the surface of the Earth. The pilot notices this altitude change and corrects this by climbing back to his 8,000 feet, but this is not the correct altitude for the local pressure area he is in. He is now higher than he should be and becomes a hazard in the sky. The calculation for how much higher he now is by subtracting the incorrect local altimeter setting from the correct one and multiplying this times 1,000. In this case, it is 30.22 minus 29.72, which is 0.50 times 1,000 gives us 500 feet higher, since he flies in a higher pressure area than his altimeter is thinking. As already mentioned, altitude is the vertical distance above mean sea level, using the local pressure of the area as a local altimeter setting. This local altimeter pressure setting can be viewed as a line, level, or plane, from where the vertical altitude starts. The pressure plane, where the average pressure level is calculated, is called the standard pressure plane and is set at 29.92 inches of mercury. Vertical above this standard pressure plane, we can measure the pressure altitude, or when between 18,000 and 60,000 feet MSL, the flight levels. This standard plane is above or below the local pressure plane of the area you are in, depending if this local pressure plane is higher or lower than 29.92 inches of mercury. It is important to remember that an altitude, pressure altitude, or flight level is always measured above a reference pressure plane. In case of altitude, it is measured vertically above the local pressure plane, and pressure altitude or flight levels are measured vertically above the standard pressure plane. Here you can see two different relative positions of a local pressure plane and the standard pressure plane, one above the other, depending if this local pressure plane is higher or lower than 29.92 inches of mercury. The standard lapse rate reduction for pressure is about 1 inch per 1,000 feet. The standard lapse rate reduction for temperature is about 2 degrees per 1,000 feet, and the standard temperature at mean sea level is about 15 degrees centigrade. Pressure altitude is measured vertical above the standard pressure plane of 29.92 inches of mercury and is altitude, compensated for non-standard pressure. The calculation for pressure altitude is to take the runway altitude and add to this the difference between the standard pressure and the local pressure and then multiply this by 1,000. In this example, 100 feet plus the difference between the standard of 29.92 and local 30.22, which is negative 0.3, times 1,000, which comes to 100 plus minus 300, what comes to minus 200 feet pressure altitude, almost the same as the altitude of 100 feet. The closer to sea level you are, the smaller the difference. Density altitude is pressure altitude compensated for non-standard temperature. The higher the density altitude, the lower your aircraft performs, since higher temperatures make the air less dense, so less air is available for engine performance, less propeller bite, and less lift produced by the wings. The calculation for density altitude is to take the pressure altitude and add the difference between the local temperature and the standard temperature, and then multiply this by 120. The pressure altitude is minus 200 feet, plus the difference between 25 degrees centigrade minus the standard of 15, which is 10 times 120. That comes to minus 200 plus 10 times 120, which is minus 200 plus 1200, what makes a total of 1000 feet density altitude. Thanks for watching, and perhaps until next time.